Okay, we'll make a start if we may. My name's Steve Cummings. I'm the Pro-Vice Chancellor for Research Innovation here at Teesside. I'm delighted to welcome you all, both in the room and colleagues and friends and family, presumably, Farzad, who may be watching us online. It's a pleasure to introduce Professor Farzad Rahimian's inaugural lecture. Farzad is the Professor of Digital Engineering and Manufacturing here at Teesside University's School of Engineering, Computing and Digital Technologies. Farzad's career began in 2002. He graduated with a Master's in Architecture from Sahand University of Technology. He then went on to complete his PhD in Architecture at the University of Putra, Malaysia, and a postgraduate certificate in Teaching and Learning in Higher Education at the University of Central Lancashire. Professor Rahimian has a robust research record, delivering more than 150 publications with more than 2,200 citations. His successful research record is founded on decades of experience working in academia in areas including digital architecture and IT, integrated design and construction, as well as 15 years of working in industry as an architect, both in Iran and as a full member of the Chartered Institute of Building. His research focuses on areas such as Construction 4.0, including smart contracts, building information management and modelling, distributed big data, machine learning and smart homes, as well as many other areas. Farzad has also successfully led several high-profile research projects from funders including Innovate UK, the Arts and Humanities Research Council, and Construction Scotland Innovation Centre. Professor Rahimian has held numerous academic positions, including leading roles at leading international journals. He's currently Editor-in-Chief of Smart and Sustainable Built Environment and Associate Editor of Automation in Construction. So it's a great delight to welcome Farzad here. I'm really looking forward to his talk, and with that, Farzad, I'll hand over to you.
Thank you so much, Professor Cummings, and thank you everyone for coming, and thank you everyone on YouTube watching this presentation. As Professor Cummings mentioned, just a recap of the most important parts of my career. I'm Professor of Digital Engineering and Manufacturing at Teesside University, visiting Professor of Extended Realities in University of Florence, and Editor-in-Chief for Smart and Sustainable Built Environment, and proudly Associate Editor for Automation in Construction, which is the world's #1 journal in civil engineering and construction. A little bit about my career, as Professor Cummings mentioned, this map is me. So basically, my almost 20 years academic career, I worked with people, around 70 co-authors and collaborators from all the 5 continents and over 11 countries, and I led several research projects exceeding 1.8 million research grant as principal investigator, 1.3 million at Teesside University during my almost 4 years here, and my publications, as Professor mentioned, 150 publications, over 150 publications, which received around 2,669 citations. I published 6 books in the area with the major publishers, and have 1 book under publication. What happens with today's lecture is basically, this is a preamble of what I'm going to talk about, and is almost some abstract of the book that we recently published in 2020, and is how our very lazy industry is going to cope with a lot of shortcomings that I'm coming back to it, to deliver what is not being able to deliver so far. And the main objectives of what the research of people like me in the area of digital construction is to secure resilience, flexibility, and competence for this industry by adopting some emerging technologies, from data-centric models, IoT, hyperconnectivity, automated systems, etc., etc. So let's change the topic. This is where my career, my serious career started. 2013, I was watching TV and this ad was keeping coming to our attention. Honda was pushing this ad by just proudly shouting, everything we do goes into everything we do. And this was when they were celebrating 99.8% efficiency in their production. And that's excellent. That means almost no waste. And they were just very near to Six Sigma. And that kind of intrigued my research. First of all, I bought a Honda car and I had a very happy life with it until I had an accident. It was written off. For 6 years, I never had to go in a garage, anything, just petrol and water, and that's it. But what happened after that? I just thought, if they are so good, how good are we? And I knew from the literature. In that time, I was at University of Central Lancashire. I worked with Lancashire Best Practice Club, my very good friend, Professor Martin Brown. We just started a mini research funded by the university. We sent some of our students to typical construction sites and asked them to just observe what's going around and asked them to code some of the activities as productive, non-productive, productive support, and statutory. Just to put it in a very simple way, if two guys are just laying some bricks to make a wall, masonry wall, if that wall is done correctly, they are doing something productive because it adds to the body of the building. But if they do it wrong, in the first place, that work is non-productive because it has to be demolished. But the work to demolish it, the work to clean the debris, the work to bring the materials again, and the materials itself has been non-productive. If we are lucky, the next one will be productive. And some things that are productive support are unavoidable. They don't add to the body of the building, like scaffolding. You can't make a building without scaffolding, but eventually they will be removed. But the question is, can we just optimize use of them? Can we shrink it? So the result was very shocking. So if we just look at the level of this productive support, which could be cut in half, and put it on top of this red, we would have had 50% waste in our industry. So I made another advert for ourselves, and just very similar, but if I ask Professor Benga sitting at the back, read my advert, I just trying to see how visible is it. Can you read this little?
Construction, everything would be good.
Yeah, good job. Then I hit that so well that you could not read it. I said almost half of everything we do goes into, and this is the reality of our industry. We are terribly bad, but we hide ourselves behind that good face, and we show that we are so good. And why we are not exposed? Because we don't have competitors. In other markets, if anything goes wrong with one of the manufacturer's car, they will lose their share in the market. But no one can come and take our share in the market because we dominated it and we don't have competitors. And all of us are as bad as each other. So we are quite secure. If you think we are a small industry, no, we are not. And we hold 70 to 80% of the GDP of each country. That means every year we are wasting trillions of dollars by the mistakes that we make. And who pays for it? These are the societies, the communities, the people, the taxpayers. They pay for our mistake. And this cartoon, I'm not trying to entertain you. If it's the first time you're seeing it, if you search for the tree swing cartoon, you will see thousands of variations of it. But one thing I want to show here is this cartoon was drawn in 1970. And since then, people are having fun with us. And we are struggling to get out of this mess. And probably even before. The first report that I've seen talking about the root of this problem 1934, Alfred Bussum, probably there are some older than that, everybody is talking about the root of the problem, which is the problems of collaborative working. And since then, a lot of good ones are coming out. I didn't have a space here to put Farmer's Report, which is 2016, which everybody is saying what the problem is. But the problem is we can't solve that problem. And again, I shall back why we can't solve it. This is one of the best reports I've seen in my life. And in early 2000, early 21st century, it came out, building down barriers, when construction industry let down the client, which was British Marines, and a lot of criticism on the industry. And this report came out and with some certain action points. Again, I teach this slide in one session of my lecture. I'm not going far into the depth. But what happens here is these 6 action points: understand the value, collaborative relationship, integrated working, collaborative costing, continuous improvement, and leadership plus people. If they were taken into account that time, we would have been in a very much different position than we are now. So why do you think all these are important? This is the chart by Royal Academy of Engineers, and it shows the implications of the decisions made in the design stage, at engineering stage, when it goes to the business value, and they amplify tremendously. So if a little mistake made by us, the designers, the implications will be huge in the long term. So if you think what implications, what mistakes I'm talking about, these photographs are not Photoshop, they are real. We do see a lot of them in our real life, designed and implemented by our colleagues, who are supposed to deliver quality products to the society. If you find them funny, I tell you a funnier story. I was the supervisor representing the client for this building. It was the second tallest building in the country in Iran that time. And it's just like 40 odd stories plus a shopping mall, 8-story. And what happened, that shopping mall had to have, was supposed to have an escalator like every other shopping mall. But then when it came to the installing that escalator, they found that the cage is smaller than the smallest possible escalator in the market. So what was the solution? To demolish 8 floors to fit that escalator. And people from structural background, they may understand that what is the implication of that on a tall building like that. And that took ages for people to re-intensify the structure. And forget it, the dust and noise for people working in that, constantly for 3 years, people with the jackhammers demolishing concrete. And that problem could have been easily rectified by stretching a box a little bit bigger if people had that knowledge in the beginning that that box had to be bigger. This is the diagram of life cycle and opportunity versus cost of the project, which is very natural to understand but very important. During the project life cycle, the opportunity for making changes at the beginning is very high. It goes down tremendously when we go along the project. But the cost is very low. Contrarily, it goes higher as we go along. In our industry, we find out here about our problems, and we solve the problems here, which is the construction stage. And why do we find out here? Because this is the first time all the drawings from different parties come together. And that's where they meet each other. And when we put them together, we find that things don't match with each other. But what if we could just bring these to the earlier stages? Then we will find out earlier, and we will rectify problems with no cost and with a lot of chances to do it. Don't blame ourselves much. This is our supply chain map. And we are not car manufacturer. We are not aerospace. We are not any other. We are dealing with a monster that has loads of components in. And nobody has any knowledge of where these come from, how do they match with each other, and that's the source of problem. But with the new technologies, with the emerging technologies, things are changing. And a lot of people have been talking about digital technologies. They believe that this is a solution for construction industry. We had like maybe over since beginning of IT, people talking about IT as a solution for construction industry. In 2016, UK government mandated building information modeling using any publicly funded project. That has a funny story behind how it's implemented, but still people realize it. But we are dealing with a phenomenon which is an elephant in the room. People see it from their own perspective, and they each have their own understanding of what it is. My friend again, Martin Brown, in 2011, defined the BIM, or digital engineering, as a total collaborative and virtual modeling for all aspects of the facility prior to construction, during construction, and in use. This is the definition that I'm interested in. And the entire my career, my research has been all around it. Use of these technologies for full integration of the whole life cycle of the project. If we want to make an impact, this is the only way forward. So a lot of people argue that we have adopted these from them. For example, oil and gas, aerospace, automotive. And I would say, yes, they are right. But reason why the same people make software applications for us, they make it for them. But in 2006, I was fascinated by an article I read about how people engineered, used a software application called CATIA for the digital design of the Boeing 777. And that was an aircraft with 150,000 pieces. They put collaboratively in among 13,000 engineers, and they shared it within so many countries. And I was just thinking, and now I think, if you ask me after 300 years, where do I want construction industry be? I would say there. This is the ultimate solution if we want to achieve a goal. If we reach there to have one model shared in collaborative environment on cloud among all the parties involved, that will empower our clients, our engineers, our designers, everybody will facilitate and streamline our supply chain and will streamline our manufacturing and production, and we will have none of those problems. So then if you ask me what I would say these technologies will apply for, I would say everything from topographical surveys to geometry, semantic, visualization, simulation, export, import. And that's why if you look at my own work and publications, again, that just spans across all these fields. Basically, what is the value of digital engineering or anything? I'm using the RIBA plan of work, and this explains where the problem is. It's not that one team works across all the stages of a project. Teams change. Every time a team passes on information from one team to another, there is a loss of information. And this loss is bigger in one stage compared to another, but at the end, in the handover, when the poor client gets the project, they get this. They get this, and they have to live with all the problem of maintenance of that building forever. And there was a case study in Paris, a mega project, a hospital. They wanted to digitalize their drawing for that hospital. The drawings were already digital, but some people printed and delivered like this to the client, and that was a 5 million euros project. And I don't think that was so successful, but at least they had some understanding of their asset. So with all these, we are looking at the tools to be used for management more than anything else. Just to cut the long story short, we are just dealing with a problem like this. This is a monumental problem for our industry. We are operating in exactly the same way that ancient Romans or Greeks or any other people work. We exactly working with the same way because this is our industry. The cart is our industry. We've been pushing and pulling it for centuries, and the problem is the wrong wheels, which are already available all around us, but we are always too busy to think and make a reflection to understand how can we make changes. But when we have to, we had some good exemplar. One of the projects delivered by Teesside University, Professor Nashwan Dawood's team, this shard building designed and delivered by Lingaro. The 4D plan of this was designed and delivered to a level that, because what happened in the part of London, later when they wanted to build this building, they wanted to capture the whole footprint, whole land of the building. They didn't have any little space for storing. And the entire building was off-site manufactured in Bristol and transported to London. And even they could not enter the city anytime they wanted. They had to wait until 9 o'clock p.m. then enter. When they come, there is no space to store anything. It's just simply take it and put it on the building. So if one mistake in the planning, the entire project, like a domino, would collapse. But it was done up to perfection. And if I just want to explain how that worked, I'm just adopting the definition of Taiichi Ono for lean design. I said BIM is to produce right product at the right time in the right quantity for the customer and to produce exactly what you need and nothing more. This project and a project like this would tell me exactly the same thing. And this project would have no waste if it's planned to that level. So my serious part of my career, it started when I was at University of Strathclyde in 2016, when I established a research group called Innovative Construction Technologies and Building Information Management. That research group was a very successful contribution of mine to the country. It delivered a lot of successful projects, a lot of researchers forged their career in there. And we worked on advanced manufacturing technologies, integrated facilities management, intelligent decision support system, and et cetera, et cetera. To make this talk a little bit more tangible, I'm going to show some of the examples of the projects that we developed, and just to open some room for discussion. This was one of the most successful projects that I had. In 2017, we kicked off a KTP with a company called Northcott. We are still in collaboration with them. We're working with them because of the successes of the project. And this project was about use of open BIM and virtual reality integration. And what happened, this company had a huge capacity for delivering high quality kit homes, but they did not manage to secure enough projects because of their location, which was very north of Scotland. This is where it's just like Wick is a lane end, and it's just like end of the country. For them to secure customers and projects who are willing to invest few $100,000 on a home that they're not sure about how it will look like without any access to them or without having showroom, it was impossible. What we did, we created a game-like environment in game engines. We started in Unity, then moved to Unreal. And what we did, we integrated IFC, Industry Foundation Classes file of BIM. We started their BIM library from the scratch, empowered the company to use digital technologies. And we reached to a level that the company had this design toolkit, which was very similar to what you can see these days in all these kitchen designers like Rent Kitchens or B&Q, etc. Sitting face to face with a softly trained marketing staff, sitting with the client and changing all the components of the building, and clients seeing all the changes, implication of the changes on the cost, everything, and they see in real time with a very high quality, near to reality quality, even in VR, or they could see it on their mobile applications, etc. And they make a decision. And the house they will get delivered at the end of the story will be exactly what they saw. And that made an impact on boosting the company's sales. I'm just showing. This is an example of parametric design that interface we developed that time for this. It's just like drag and drop modules, just taking modules and putting there, and just to give the customer idea about the furniture of the end product. So with this project, the boost of the sale, the success of the project was so tremendous. First of all, the innovation of the solutions in 2017, we received Innovation of the Year award. 2018 we received Innovation of the Year award from Scottish government. In 2018, we received Building Smarts International, which is the highest forum in the world in looking after BIM award for the project we developed. And finally, we received outstanding grade for our KTP. And just so that you know, makes me very happy to share, the KTP associate who finished her PhD in Teesside University, immediately after graduation was attracted by Cambridge University with a very high competitive salary as senior research fellow to move to the Future Roads project. So this is the impact of the project. Another project that I was so proud of it, and again, one of my best colleagues and students and friends worked on it as a PhD student, was the collaborative project with a company called Urbanco in Glasgow. What Urbanco does, they had a system. Again, the system itself was created by one of my PhD students in Teesside, Stephen Oliver. The engine gets the SBEM model of a building, which stands for a Simplified Building Energy Modeling, and automatically generates EPC for commercial buildings. And because of the mandate by the government for every commercial building to have that EPC, otherwise they could not lease their building, they had a huge market. And what their product also did, it gave them some guaranteed guidelines for improving their EPC. Like if you change the windows, your EPC will jump from E to B, and it will cost you £50,000. But what they did not do, they did not give the best solutions to the customers, because what they had was based on the static solutions, not on dynamic and AI-powered solutions. We suggested to them, why don't you just develop some genetic algorithm or AI application for this? They said, we tried, but it didn't work. Let's try again. We had a case study, and we tried it. The cloud computing cost for one single calculation was £1,000, whereas they were charging the customer only £200, and it took 1 week to complete it. That means it's impossible. And what we suggested to them, they said to us they have access to the data of meter use and SBEM data of 50,000 commercial stock in UK. And we said, why don't we just design an emulator. We called it emulator, which is basically a simulator, but we didn't want to call it simulator. So we trained the database, and that sits between the actual design builder or Energy Plus or any other simulator, and check the solutions coming from the AI before it goes to the simulation, and based on the historic data, decide whether or not this is worth for simulation. With that engine that we developed, we managed to kill the solutions from hundreds of thousands to less than 100 with only 4% error. And that was the project which was patented and was commercialized by the parent company in the States. And the turnover of that project is exceeding millions. Another very interesting project, if I ask people, first of all, do you know this lady? She looks very nice person, isn't she? If I ask you, do you know what is the biggest scam ever in the history? With the clue that I'm showing you. You tell me. This lady, she stole $4 billion from innocent people by a cryptocurrency that she invented by herself and called it OneCoin, and she called herself OneCoin Queen on SQL database, and she disappeared, as easy as that. And people lost their money. And that's exactly where the problem started. This is another piece of a scam. This is the biggest one case scam. That's the biggest whole case scam. This is the biggest one case scam. Somebody, their name has not been revealed, purchased this painting, which was claimed to be painted by Leonardo da Vinci, on a sale for, I guess, $2 million or something like that. Sorry, 400 million. I'm a bit confused now, I have to double check, but with a very huge price. Yeah, I think it was 400 million. Then it appeared later that it wasn't painted by Leonardo da Vinci, and it was done by his one of his apprentices, and the price dropped to 400,000. And this is the question. If we had somehow unchangeable track of history of this artifact, would that be happening? So this is the other sort of research that we've been working with one of the very strategic partners of university, Yonder Data Centers Group, and for almost 3 years we've been working with them for development of a smart contract and digital twin and blockchain system for facilitating the commissioning stage of data centers. Because in a data center, they are dealing with hundreds of thousands of assets, each delivered and commissioned and installed by different vendors. And they have no clue when, who is coming there. To a place that even a firefighter cannot enter without being accompanied by a patrol. So that's a very costly stage to bring in, test in, and install the equipment. But if we simply automate it, and just asset comes there, logs in, saved in the block, locked and secure, no one can touch it, no one can change it, and by automatic verification, 3D scanning, geometry testing, yes, the asset is right, and tick. As easy as that. Again, this is a project at a very infancy stage, but it has a very big potential. So another project that we started, and myself and Annalisa with some of the students are just developing a new version of it with one of our clients, Nycander. It was initiated in 2018 with the funding I received from Advanced Forming Research Center, the Innovation Center, and it was £50,000 only route to impact research, and we developed the AI-assisted photogrammetry with the help of the deep learning for automizing the construction processes, and we call this virtual photogrammetry. And again, I don't want to go too much in the detail, but the outcome was so successful. The paper we published in 2020 is on the highly cited list of automation in construction and competing with much older papers in their field. And this has been now a reference for so many other people in the world working on deep learning and image processing. Another project that we conducted with Northcott, and again recently, gladly I heard that the project received outstanding grade from Innovate UK, was the WellBe project. We helped Northcott for adopting smart technologies and user-centered design for helping people, especially the elderly. We call it forever home design, to live in their home with the aid of some plug and play devices. That imagine somebody is buying a house today, they are at 40s, they don't necessarily need to add so many features to make it future proof for their potential disabilities or during their the older time that they need more help. But this house must be capable of adding these. And again, these features have to be capable of being brought in and brought out, because they are very costly solutions. And with this project, we've been, and this is an again unfolding story, we had some very good applications submitted to Innovate UK, but because it was submitted to Smart Grants, although it scored very well, wasn't successful. We are planning for further exploitation, but the full story will be a very smart house equipped with all the smart devices, with all the AI-assisted calculation for helping people to have a healthy life in their home with the least cost implication. So this is the map for WellBe, and again, a lot of our colleagues, Claudio, many other colleagues from the university are partnered in future plans for this project, and it brings in a lot of features. This is the project, probably my most favorite project of my career. Again, Annalisa and I are still working on a KTP with this company, and we had accelerated KTP, and we recently exchanged MOU with this company, and there is a big future for our collaboration. What happened? In 2018, we started a GAP project, and that project was we just visualized the tunnel, which is the world's second longest city tunnel, the Stockholm bypass, in game engine. And that was the aim was a digital twin. But even in the middle of the way, the client of Nycander, they decided we're not interested in it. We don't really think we're going to have value out of it. But Nycander decided to continue this journey with us. And they embarked on a KTP. And a few months ago, we heard the same company have told them they're making €1 million saving a month by this decision-making support system, which is still evolving. We just kicked 6 months of a 30 months KTP, but again, we are planning for so many other evolutions of this project, which is making a digitally enabled application for them, which is data-driven, a surrogate model enabled from the historic data, from data coming from sensors, from generated data for controlling the traffic management, for optimizing traffic management of this tunnel. So, yeah, cutting the long story short, I'm trying to save some time for questions and answers. What is all the projects that I've been talking and all the concepts about? Is if we look at this oval, what is in the center are the enabling technologies, from IoT to machine learning, smart sensor technology, big data, computer vision, offsite manufacturing, etc., etc. To do what? To generate these benefits for the industry, which has been suffering, as I said, for centuries, with the deficiency of their HVAC, with health and safety, security, with occupant thermal comfort problems, low emission, and all of these benefits can come from this oval. And this is the entire story that the research of somebody like me or any other colleagues in the same field are interested in. These are some of the publications I mentioned. I always try to stick to the highest quality of journals rather than going for lower hanging fruits, just to make sure that whatever we do reaches out to higher level of audience. And thank you so much. I stop here and I just encourage everybody to ask questions.
Thanks, Farzad. So we have time for questions. I'll take questions from the room first. I think there may be questions online. So is there any questions for Farzad?
Yes, Anna.
Thank you for the talk. I just had a quick question about the applications of AI for what you do. So you've been showing different applications and how AI is actually enhancing engineering and constructions. What do you think will be the future in terms of how do you see AI actually helping this field in the next, let's say, 5 or 10 years?
It would serve in many respects. And again, I come back to the first thing I mentioned, the whole life cycle. It could serve the businesses in scoping the market, in finding out what are the future, what are the trends in the market for their future investment. It could optimize the design stages, because one of the slides that I just fast-tracked was showing our waste in the engineering work in the construction industry is 20%. And that's a very, very high wage industry. So if we could just optimize these design stages by decreasing the number of iterations, again, that 20% is a huge saving. In the construction, the waste is very high, and AI, the new Horizon Europe project that we secured, Reconstruct, is all about construction waste optimization. And that is a tremendous area of support. And mostly in the facilities management and use, which is the biggest area when it comes to HVAC optimization in energy distribution systems, etc. These are the things AI in conjunction with cloud computing and IoT would serve the industry the most. You're welcome. Thank you so much. Yes, Claudia.
Great talk. So yeah, you mentioned several applications for automation, optimization, and machine learning. You also probably mentioned that this field is really lag behind in terms of adopting these technologies compared to maybe biomedicine or even other fields in engineering. So what went wrong in your opinion? Is that because maybe there were solutions, there are solutions, but they're just not optimal? Or is it something else?
It's an excellent question, Claudio. And again, this is one of these things that I just like maybe spend a few weeks of my teaching to discuss about the root of problem. We My book on the first page, if I may go. 1 second. This book, Offsite Construction, it is like the whole book is around 3 themes, which are people, process, technology. And the argument of the book at the end is that there's no problem with the technology, and the technologies are already available. There are 2 problems. One is the people. We do not have that luxury of highly skilled and trained staff. And the other problem is the processes. But if you come a little bit further into the depth, the problem is, as I mentioned in the beginning, we do not have competitors, and we are not forced for the change. And because our work is a little bit different from every other systematic manufacturing, we were kind of firefighting system. Like in a construction manager goes to work to rectify any problem that occurs. It's not that a future planning, proactive management. For that reason, we never had that chance, our industry, to sit down and find out what would be the best for them. And what we can see happened in UK and other countries, without that government mandate in 2016, wouldn't have happened here. And again, that mandate, which clearly says every publicly funded project has to be BIM enabled. I speak to many friends working in professional design firms, etc., and ask them, what do you do with BIM? They say, we have BIM consultant. I say, what is BIM consultant? Then I find out that they do the project in a normal way, and they give it to a consultant, and they make it look like a BIM. Whereas the entire story about BIM is to facilitate collaborative working and integrated working for them. So we're not still getting the benefit, but at least by knowing that we have to, we started the journey. Thank you. Yes, Caleb.
Thank you for that. No, I was going to ask about the undertaken and particularly that £1 million a week you think that they were saving. Was that to do with, was the data they were referencing, was that data that had been collected on site using metric data, or was that because it had been predicted previously in the design stage? And then basically were they saving their money because they were collecting data, or because they were able to accurately predict where expenditure would be?
Nycander KTP is not data enabled yet. It's not data driven. The only the visualization interface which helps them to sit down in a room, like for example the training. In a tunnel that people, the cars are driving in it, how do you think you can train your staff? That's a big story. But now with that digital twin, if you like, training staff is just as granted. You can show them everything exactly where it is. For a decision support, people sit down in a room, in an observatory or any larger screen. They could just look at where they want. And again, if it goes a little bit further, with the example of Yonder I told you, one of the things that Yonder has achieved with this digital twin that I was mentioning, at everybody's home, we have some false fire alarms, right? Something could happen and fire alarm can go on. These sensors could easily be diluted. In a data center, that would cost thousands to go and check that, see if it's a fire alarm or not. Because it's not that everybody just enter. There are a lot of processes to go and check one single fire alarm. Now, what happens? They have these robotic dogs mounted with the thermal cameras. Any alarm on the system, the dog in 20 seconds runs there and scans the surface. If it's not hot, communicates back to the center, it's not hot. Then the person sitting in London or New York or wherever just clicks on a button and turns that alarm off. As easy as that. So this is the level of things that you would get from an IT interface or model, even without thinking in the beginning that you would get. And again, back to your own project, the doors that this project is keeping opening for Faraday, we didn't have any clue about what they will get. But the more you go further, the more doors open automatically as the byproducts of that engine or the model that you have in your hand.
In the next 10 years, what are the skills that will be needed in the AEC industry?
This is a very good question. Thank you so much. I think we have to really revisit our education and training systems. There is a question always I ask in some of my slides is that do we learn to build or do we build to learn? So far in my career and many other people from my generation, we build to learn. We go and waste people's money. By practicing, we learn that tacit knowledge. And or when we die or when we leave our job or anything, all that tacit knowledge dies. But one of the things is that we train our students with those skills. And what are those skills? Is that they must be capable of using these tools that are, we call it a digital literacy or whatever. At least they must be capable of generating a BIM model. They must be capable of sharing the model with their collaborator. And so far, in the country that is definitely leading in the world, UK, is not happening. Our people, professionals working in the industry, they are not able to use Revit, which is the simple like alphabet for when you're talking about digital engineering. These are the technologies, but then when we go further, some specialist people, they have to be able to collect data, analyze data, and model it, and so many other things by integration system like cloud computing, IoT, all these things as other industries need, our industry also need.
So I think that's all the questions. Can I just thank you again, Farzad, for an outstanding talk and sharing with us your extraordinary projects and the great work you're doing. So we can just thank Farzad again.
Thank you. Thank you so much.
I think I've already had the